Okay, so for this one here, we're looking at the cosine ratio being given in different form. It's been given to us in an arc-cos form, but still, again, we need to recognize we are dealing with an arc-cos ratio, but this is our cosine ratio here. It's just telling us that the angle, given the ratio 5/8, is equal to theta. Now, the nice thing about this is we've been given the ratio, so we can draw the picture of this. And we've also been given the quadrant. So when we draw this, given that quadrant, quadrant 4, I can draw it like this: 8, 5, and there's our theta. Now we can measure it going backwards, but we're going to measure the positive version of this. So there's our position. That point there, again, is our important point because it establishes where we are in the space, in the 2D space here. Okay. I want to now find sine, tan, and solve for theta. First of all, I'm going to solve for sine and tan. So I need to use Pythagoras, and it's implied that you keep exact values. So I'm going to do 64 minus 25. That's going to give me square root of 39. Okay. So this is, well, it looks pretty good, except that square root 39 is not in the right direction. I'm going down. So it's very important. So I'm going to highlight this. It has to be negative root 39. If I don't have that negative in there, I'm in the wrong spot, and that just totally blows the whole purpose of positioning, or standard positioning. So now that I have my positions all figured out, I'm going to write my sine ratio. Sine theta is equal to negative root 39 over 8. My tan ratio is my slope. Okay, so it's going to be down 39, rise over run. Yeah, that line has negative slope. Okay, and then solving for theta, I'm going to use the arc-cos to solve for theta. And remembering that, I have to remember that I have to consider two angles here. Although I know which one, I can eliminate one of them, my calculator doesn't always give me the right answer, because it could give me the other angle. And in this case, when I do arc-cos of 5/8, I get 0.895. So I'm going to round that to 0.9. So 0.90. Well, 0.90 is not in the right quadrant. That's not what I'm looking for. Okay, so although that is, I'm going to draw this one in red here, theta 1, it's over here. It's in this quadrant. It's at that spot right there. Okay, so there's my theta 1. There's theta 1. Wrong spot. I want the other angle. I want, which I'm going to call theta 2. So that's the one I want there. So theta 2, based on the symmetry, well, it's really, I can say it's just negative 0.9, but I'm going to rotate it this way, so I'm just going to do 2 pi minus that. That will get me to the same spot. So that's going to be 5.38 radians, approximately. Okay, so this is same types of problems. We've been given, in this case, we've been given the ratio negative 3, 5. It's in quadrant 3. Okay, so I'm going to draw this. So that's cos is x. So 3 in the negative direction, 5 in the positive. 5 is my radius. Okay, it locates that position right there. And there's my angle theta. Okay, that's what I'm looking for. Solve for the third side here. It's going to be 4, but remember that it's negative 4. Again, I'm going to highlight that because it's important that it's not just 4. It's not a triangle. It's a positioning. So then we can solve for, we can write the sine ratio. Sine theta equals negative 4/5. The tan ratio is negative 4/3, or positive 4/3, because yeah, that's positive slope. Okay, and then it doesn't say to solve for theta, but let's solve for theta. So I'm going to use the arc-cos for theta again. So we're going to go arc-cos negative 3/5. That negative is important. Is equal to theta 1. And my calculator is going to give me a value of theta 1, negative 3 over 5, of 2.21. Okay, so 2.21. Now, is that in the right quadrant? Okay, well, 2.21, if I know my pi's, that's going to be 3.14. That's in the wrong quadrant. Again, I've got this, although my calculators give me that, the positioning is over here. It's right there. There's my 2.21 angle. Okay, so 2.21. I want the angle down here. So again, I'm going to use my symmetry from this side. Okay, and I'm going to do theta 2. So my theta 2 angle, theta 2, I can say is negative 2.21. That would be correct. So yeah, let's write that down, negative 2.21. Or we can use the angle going in this direction, okay, which is pi, 2 pi minus 2.21. So what is that going to be? 2 pi minus 2.21. I get 4.07. Okay, so those are coterminal angles. They are exactly the same position, but going at it from different. One's negative, one's positive. Okay, so let's do another problem here. So I've got an angle theta, and I've got another angle alpha. Okay, so let's draw the angles in previous position. Okay, so this is going to be down here. Okay, so it's going to be negative 3, negative 4. Okay, so there's theta. Okay, and I want alpha. Ooh, that's going to give me, I need to rotate that 90 degrees. Now, if I rotate it 90 degrees, okay, I'm going to end up right about there. Okay, just draw that a little bit more like that. Okay, and that's going to be 90 degrees. Now, I'm just going to draw my reference triangle, and I want you to notice something. If this is a 90-degree rotation, this y and this x kind of match length. This x and this y match length, and they do. This is when we do 90-degree rotations, we can expect the x and y to kind of switch. Okay, now they don't just switch normally, because now this is positive and this remains negative. So I'm just going to write it in negative 3, positive 4. So there's my angle through here. This is going to be angle alpha, which is equal to theta plus pi over 2. Okay, so that's my new position. And I can figure out my x and y position of that by just using, x is 4, just using the positioning of that. Okay. Now, in general, if we want to know 90-degree rotations, okay, if I start with xy here, a 90-degree rotation over here is just going to switch y and x, except this is going to be, the y is going to become its opposite. Okay, so it's going to go in the negative direction. It's going to go left first. If I go 180 degrees, from here it's going to be, it's going to be x and y, but they're going to both be negative. Okay, and again, if I do from here, I can switch x and y and make the x negative. Here, it's going to be the opposite of that, so it's going to be y negative x, or again, I switch the x and y's and make the x the opposite of what I started with. So in the case, negative y becomes positive y. So we can make this kind of generalizations with 90-degree turns. Okay, so that's one thing. If you want to do this geometrically, we can. Okay, later on, we're going to work out how we could do this algebraically with identities. Okay, so without using your calculator, I want you to determine if sine of 210 is negative. Well, to do that, we need to establish the position of 210, and we know that sine is y, so it's going to be negative. Okay, cosine of 4.3 radians. Well, 4.3 radians is somewhere around here, right? We know that this is 3.14. This is going to be 3/4, so 4.72, I think it is, or 3 pi divided by 2, 3.71. Okay, so we know it's got to be somewhere in here. Okay, cosine is x, x is negative. Okay, so we know that that's going to be equal to a negative. 4 pi over 3, where is that? First of all, that's going to be down here. Okay, and we know that tan is slope, so tan is positive in that quadrant. Sine of 430 degrees, well, where is 430 degrees? Well, it's 360 plus 70, somewhere around there. Well, sine is y, so that's going to be equal to positive. Okay, sine is y, x is, so cos is x, tan is slope. That helps you establish the positivity and negativity of those ratios and what quadrants they can and can't be in. Okay, so that's the way I would suggest that you do work. Try to remember these ratios.